Okay, recording has started, and so should we be starting our lecture as well. Um, yeah, this is a very interesting phenomena, I would say. It's a picture, of course, picked from, I think, the book of Lutens and Zerberg. Yesterday, we went into understanding the classification of various types of air masses. We classified them geographically, we classified them thermally, we classified them dynamically. Okay, and you'll see that how the sizes of these do change. Okay, with regards seasons also is so very important. Okay, today we'll go ahead with something which actually is learned as the frontal theory or frontogenesis. But in our syllabus, it's required in a different way. So we are going to approach it in a different way. What you see in front of you is basically a weather map. And what does it all show? Okay, let me just identify a few things for you all. By the time I adjust my stylus, let me tell you that I was with my FIBA students and got delayed for some reasons, and that's why I postponed the lecture by 10 minutes. Obviously, we should be finishing by 11:30 for sure. Now, what all do you see here? Okay, of course, arrows are something that is so very common, but then you'll see that the arrows here are red color and the arrows here are blue color. This is red and of course this is blue. Red should be indicating warmer conditions. Blue should be indicating milder or colder conditions. One thing. Secondly, you should be able to identify these abbreviations. Okay. As I said, North American continent is a typical continent as far as representing various types of air masses. So you'll see that the colder ones. Okay. Now see how interesting it is that this is maritime polar. So this is light blue. This is maritime polar light blue. However, when they are pulled on land and when it goes down from here, it starts getting darker blue and it tends to be continental polar here. This is the advance of this air mass, and you'll see that this is called as a cold front. Okay, the word comes from because this was FR. Oh, sorry. Let me just. Okay, this is called as a front. Now, the fact that a lot of research about this was happening at the time of the Second World War. Okay, maybe army fronts was something that was much in discussion, and because of this term cold front, warm front came in, and the whole theory of frontogenesis is being looked up as if this is a what do you say, a friction between the colder air and the warmer air, and that's why the term front comes in. What else do you have? Above the cold front in this year, you have the warm front. Where is the warm front? This is the warm front. Who is causing the warm front? You'll see that maritime tropical. Maritime tropical. The red ones are causing the front. Now, you'll say that, sir, why is it that they are taking directions? Okay. Now, here is where in fact, I always believe that frontogenesis is the reason we keep it last is we need to apply in literally everything that we have learned and in the course of time to understand this particular subject. And if you remember, we did Coriolis Force. Okay, you'll see that here in the northern hemisphere they deflect to their right. This is deflecting to the right, and in fact, this circular portion. Okay, how the front dissipates into or transfers into a temperate cyclone is because of the Coriolis force. because you'll see that if I am to clear off all these annotations that I've put up, and I would try to make a few things. Say, for example, this is going to be your warm front, which is approaching from a lower latitude. And let us say this is going to be my cold front, okay, which is going to approach from here. They should have approached each other and they should have had a um, say mixing here, but then it doesn't happen so because of this has to move this way, this has to move this way, and in that process they are going to form a cyclone. Okay, unlike a tropical cyclone, which is a very high energy, the location, the total area occupied is comparatively low. You'll see that as far as this particular temperate cyclones are concerned, they would expand for a larger region, but the amount of destruction, the energy that they carry is relatively low. Is something that we have to keep in mind. Then, what else can you see here? You'll see that you have an alternating part of the warm and the cold front here. Now, what that is going to be called, that is called as a stationary front. That's called as a stationary front. So this is a warm front. This is a warm front, or let me say number, or say I'll write it here, warm front. Okay, this is going to be a cold front. Now, why does it why is it called so? Because you'll see the warm winds are moving ahead. Here, the cold winds are moving ahead. And somewhere here, what is happening is that you have a mixture of warm and cold front, and that's why it's called as a stationary front. Now, remember that this is basically a two-dimensional diagram, and it would be interesting to understand as to exactly what happens when we should be viewing it in 3 dimension. Okay, this what you see in front of you is 2 dimension. Now, if we are to observe the same thing in 3 dimension, this is how it should be looking at what. Okay, remember this point here. I'll just clear up this. This is point A and this is point B. What do you have? Some part of cold, some part of warm here. Okay, this is cold and warm, and then you have the region in between. Now let us try and understand how it looks like here. Okay, so you'll see that here the cold air is moving ahead. The warm is moving in a different direction, pushed by the Coriolis force. And while the cold front is closing in here, okay, some of the warm sector is being sent up, and that can be observed in the formation of cumulonimbus clouds. You can see here, and you're going to have a lot of precipitation here. Okay, on the other hand, you'll see that in the warm front area, you will not have that much of rainfall, basically because the clouds tend to be dispersed. They're dispersed. Now let's go back and see what is happening. This part is where you will have a lot of rain, because the cold front is aggressive. Because the cold front is aggressive, you'll see that the warm front is going to be forced up faster. This is going to be forced up faster. Just see the how can we analyze this. Okay, you'll see that the arrow here the arrow is very smooth. The arrow is very small, steep, and because of the steepness, you'll see that the growth of the cloud is also steep. Okay, so that is how and what actually is happening here, and you'll see that in these two conditions, that is warm front conditionally unstable air, and here you'll see the stability comparatively stable as such. Okay, what I mean to say is this part is actually this part, and this part should actually be nearing this part. I'm not saying they are exactly the same. A few things that I would like to want you all to observe is the scale. You'll see that the lengths, it's running into 1600 kilometers broad as such. Okay, now what is happening? Okay, you'll see that the warm front, the warm air is unstable basically because it's being pushed up, okay, and needs to the formation of cumulonimbus clouds, and these are going to cause a lot of heavy precipitation. As they move further, of course, they break up into smaller bunches of altocumulus clouds. On the other hand, you'll see that if the climb is gentle, okay, they will move from one to other. Nimbo, okay, they'll give some rain. It's not going to be heavy as this, but you'll see you'll have moderate precipitation here. Okay, so you're going to have nimbostratus, and then as they move ahead, the rain will stop and they will gain height as well. Okay, from altostratus to cirrostratus, and then further, the cirrus, which are the highest of these clouds, is another thing that we can look at here as such. Now, see what actually is happening. That when we spoke about uh, what should be happening at this particular point, it's the same thing. Much and last thing, you'll see that the cold front gets very aggressive. It pushes itself here. The warm front is moving in this particular way, but then the cold front, it comes, it overrides, and it pushes itself down the warm front, and as a consequence, the tail part of it tends to be pushed up. And in this pushing up, you'll see that it leads to the formation of cumulonimbus clouds, and these are going to cause not only cause heavy precipitation, you'll see you're going to have lightnings also here. Okay, but you'll seldom hear that these cumulonimbus clouds in the temperate regions have caused very heavy damages as such. There could be floods, etc., but very heavy damages, high wind speeds, etc., is not exactly the scenario in the temperate cyclones. Okay. Um, then this is one more scenario wherein you'll see that a mature mid-latitude cyclone. Okay, these are point A and point B. Okay, and you'll see that this is an occluded. Now these names we are going to follow it up. I'm purposely doing it in splits basically because later we are going to put them together and try to understand the Jerkin's theory. Okay, now you see that this A to B. Okay, now point A is here and point B is here. Okay, now try to compare. Okay, around A you have the cold air. Near B you have the warm air. Okay, now what exactly is happening is why this takes a turn like this. Okay, because you'll see warm air is moving like this, cold air is moving like this. Okay, so when you are going to squeeze it, okay, remember we spoke about the Eggman spiral. Okay, you'll see that it's going to be a spiral sort of a thing. Okay, you'll see that the colder winds are going to move faster. Okay, and as they move into the warmer winds, it will push the warmer wind. Just a moment. This is where the cold front is. Sorry, just a moment. This is where the cold front is. This is where the warm front is. Okay, and this point. Okay, I'll just clear it off and we'll go back again. This point here, okay, is this point here, the cold front. Let me write it here. This is cold front point, and this is the warm front point. Okay, now the cold air is going to push into the warm air, and it's going to push up this, and in this process you'll see that we from this is conditional instability, I would say, if you remember what we had done last week, a few days ago, instead of calling it last week. Okay, you'll see that condensation will take place, and this will lead to conditional instability, and it will lead to a lot of rainfall in this particular region. Okay, here rainfall, however, is moderate because you see that the air or cloud spreads over longer area. This is going to be nimbostratus. We just saw it. Nimbo means rain or moisture, I would rather say. Okay, nimbostratus. So the warm air is traveling, but you'll see that given the colder part, okay, it cannot travel advectionally horizontally, so it starts climbing. Okay, so it has climbed up here by itself over the cold air, giving some precipitation here. Here, however, the cold air makes it climb. Okay, because it is forced, you'll see that the cloud formations are a bit different, and as a consequence, along the cold front, you're going to have heavy rain. Okay, you'll see that along the warm front, however, you will not have heavy rain, and in fact, it's just beyond the warm front that you would start to be having moderate rainfall. Okay, uh, you'll see that what is happening actually is that this cold air is closing on. It's closing on this red line. Okay, and eventually, what is going to happen is that the cold air is going to stay. You'll see that this is the cold air. This is the cold air. What happened to this warm air? It has been picked up. It has been sent up. Okay, and you'll see that it is depositing moisture in the form of heavy rain as such. This is called as an occluded cyclone. Occluded means it comes to near the end process of what can be called as a temperate cyclone as such. Now, how does this process totally happen? Okay, you'll see that this is totally occluded now, because along the ground you now only have cold air. The warm air is actually lifted up here. Okay, and this is that part. No? I've seen students confuse themselves. The moment they say warm, they'll keep looking here, but you don't look here. This is the AB part of it. The whole surface is cold. The warm air has been lifted up. Okay, it is the next stage after this. You'll see that here is where the occluded front is. Some part of the warm air is still touching the surface. However, here, okay, the occluded front has say gained height. It has moved to a height, and that's why you'll see that the warmer air is completely lifted up, and what remains on along the surface is colder air. Okay, so that is it. Okay, this is how it should be looking in a three-dimensional way. Okay, you'll see that the cooler mass is moving this way, the cold air is moving this way, and the warm air has been lifted off the ground. This is the point of occluded front. Okay, cold type of occluded front. This is a warm type of occluded front. Now, how do you differentiate between this? You'll see that in a cold type of occluded front, you'll see that it's the cold air mass which is pushing the warm air up. And as far as warm type of occluded front is concerned, it is a relatively cooler air which is pushing up the warm air mass in these regions. Okay. Now, uh, I purposely put this up to you, okay, because this is a bit of more explanatory, and that some idea comes into your mind as to what actually is happening. Who brings this up? Okay, you'll see that it was around the Second World War that initially Jerkins, Bjerknes, if you remember, there are some misnomers, and I spoke about them when we met in the college for a small period of time. Okay, आणि मराठीमध्ये बऱ्याच एका पुस्तकामध्ये मी याचं ट्रान्सलेशन बिजर कनिस असं ऐकलेलं असं असं वाचलेलं आहे. It is not bijar kanis. I did mention it earlier also. It is the B is silent here. It is Jerkins theory. Jerkins theory. He speaks about the stages of life, the life cycle of a mid-latitude cyclone, or it can also be called as a temperate cyclone. As said, these are the various stages. Same diagram is available in Lutens and Turbo, but then I would take you from one point to the other. Okay, you'll see that the players in this obviously are going to be the say the continental polar air mass, and of course the tropical maritime mass. What happens? Okay, we start with point by point. Let us start with A. Point A. What happens is that you have cold air coming from this part, and you have warm air coming from this part. They meet each other along this line, which is called as the front. Which is called as the front. Actually, this theory was given in Europe, but you'll see that in this book on of Lutens and Terburg, you'll see that the application is seen on the American surface. Okay, the theory is actually given in the on the European. Jerkins was a Norwegian, I suppose, if not a Swedish. I'm confused between whether he was a Norwegian or a Swedish person, but it's a European theory. So the cold air is going to march from here, and the warm air is going to march from here. However, what happens, as I said earlier also, that while they keep marching into each other, the Coriolis force comes into option, and you'll see the warm air is moving this way. That the warm air takes to its right, and the cold air takes to its its right on the other hand as such. Okay, I would purposely now enlarge these two for our purpose. I don't want to confuse you all with pouring in a lot of information and leaving you. I've already poured in a lot of information. I would not want to confuse you further. Okay, you see that this condition here, okay, where they have just arrived and म्हणजे एक आर्मी इकडून आलेली आहे, वॉर मारी आर्मी, एक आर्मी तिकडून यायचा प्रयत्न करते. Okay, and they are just in front of each other. Okay, so this is the front develops. Okay, म्हणजे एक त्याला म्हणतो ना आपण एक division comes up in front of each other. Okay, so then uh, with movement, what happens is Coriolis force starts operating on each of this, and what has happened is the warm air is moved towards its right, and cold air is moving towards its right as such. Okay, there's a minor curvature that has now developed in this process. Now, what happens is because cold air is moving along the surface, it has a significantly faster speed. Warm air would not move that fast because it is being obstructed by say the cold air, because it's moving from a warm air into a cold air region. As a consequence, the cyclonic circulation will be established. What exactly has happened here is that uh, the warm air in its event to go into it. Now, what does this represent? Okay, you'll see that the clouds are more dispersed here. Okay, they're stratus, but they're all to stratus. But here, you'll see that the cold air is pushing itself into the warmer air. Thus, the warmer air is climbing up and it develops into cumulonimbus clouds. Okay, not as intense as the tropical regions, let me tell you, but they are giving heavy rain. Where did we see this earlier? We have seen this here. We have seen this here as well. Okay, how the cold air is. Okay, this is in fact the scenario of the third stage. This is the scenario of the third stage that we are seeing. Okay, the colder part is here, that the warm air is forced up, and this is where the warm air is gently sliding up, so the rainfall gets to be distributed over larger area because the clouds get distributed over the larger area. Here, because the warm air is being forced up, okay, you'll see that the warm air has nowhere to go but then climb in this particular format, in this event, condense and give heavy rains at that particular end, and we are referring to this stage here. Okay, in a diagrammatic form, this is how it could look. I will post you the diagram that I have drawn in the classroom so that you can use that to as a sector of practice as such. So this was stage one of frontogenesis in the theory of Jerkins. B silent ahe, you have to pronounce it as Jerkins, Jerknes, Jerkins. Okay, two winds come in front of each other, air masses I would say come in front of each other, but in the process of that, what happens is they get deflected to their individual rights in the northern hemisphere, to their individual rights. So there is a curvature and a wave develops. And eventually what now happens is this cold front starts moving into the warm front. As it moves, warm front has nowhere to go basically, because its further end is also blocked by cold front, because the warm air is entering into cold area. So you'll see that the tail of the warm, this is, let me say, the section of the warm area, this The tail is being, it's like something like this, that the cold front is pushing itself into the tail. Sorry, I will, where was it? Yeah. So this, I'll just switch it off for one moment. Okay, so the tail of the cold front is pushing into, this is the warm front, okay, and it's being lifted up. And because it is being lifted up, you'll see that it's giving heavy rain. What is happening on the frontal end? Okay, you'll see that it is gently climbing up. Because it is gently climbing up, you'll see that the rainfall is not as heavy as it is expected to be. Okay, so however, in this process, what is happening with the cyclonic disturbance is established, and you're going to have condensation at both the ends, the cold front and the warm front end. Okay, and in this process now, what is going to happen next as it further goes? Okay, this blue line, by the way, is the track of the storm. This is how the storm is going to move eventually. Now what happens here, okay, is that it reads occlusion begins. Now what exactly does occlusion beginning mean? Till here, you'll see that you had one line, you had one line, you had one line, and the the colder part was free, the warmer part was free. However, now what is happening? You'll see that the colder part is closing into, okay, the colder part is closing into, I would have been requiring someone else for, anyway. So what is going to happen is now, what does occlusion actually mean? Occlusion is basically lifting of the warmer part. Now, how does this warmer part be lifted? You'll see that towards this end, it's already going up. Towards this end, it is being pushed up. Okay, and this pushing activity for this to increase is slowly closing in. Okay, but the start of this pushing activity can be seen here, this part of it. The start of it is being seen here. I'll just enlarge it for a moment, and let me show you. Okay, so you'll see that this part, what has happened is it's like a scissor. It's like a scissor. Okay, one arm. Okay, it's one arm cold, the second arm cold air mass, and you'll see that it's being caught into this, and the scissor is started to close. The blades of the scissor, if you say these are the blades of the scissor, ही कात्रीची पाती आहे, okay, they start to close. अख्खी कात्री एकत्र होत नाही. Okay, it starts to close here. Okay, so इथे जो वॉर्म एअर असेल हा उचलला गेला, इकडचा या कैचीत जो सापडलेला वॉर्म एअर आहे हा इकडनं उचलला गेलेला आहे. अँड हिअर इज वेअर ते उचलण्या प्रक्रियेला ऑक्लुजन म्हणतात. त्या उचलण्याच्या प्रक्रियेला, द process of lifting warm air above the cold air is called as occlusion. Occlusion begins at one end, and let me again show you how it is beginning. Okay, so you'll see that this part is where the occlusion is starting to happening. Okay, eventually it will intensify. Eventually it will intensify, and this intensification will be seen here. Okay, इथे जर तुम्ही पाहिलं, this is the intensified occlusion. आणि त्याचा जर आपल्याला क्रॉस सेक्शनल हे पाहायचं असेल, okay, so see it has intensified, and a lot of cold air is now covering the surface. Okay, very small surface is remaining as far as warm air is concerned. Okay, very small surface, only this much. Okay, here it had ample amount of it. Here it was occupying its own space. इथे कमी झाला, इथे कमी झाला. Okay, you'll see that the occluded front has now developed, and it is pushing up. It's very strong, the occluded front, and it is literally lifting up the warm air mass. All this is mechanics, of course, but then this is the story how we develop around it. This is what Jerkins had to say. The fifth stage is where the occluded front closes in, and of course it tends to push up the warm front. And eventually what happens is, once the whole thing has happened, you will see that the cyclone is going to dissipate. It's going to dissipate. What does dissipation mean? Okay, and the difference between these two. Okay, this arrow is actually supposed to be here. Okay, here what has happened is there is a small amount of warm air which is remaining for this to be pushed up, and in this process, see what is happening is that a small, say the cold front is closing in. In this, the F diagram, the cold front has absolutely closed in. So the blue arrows are at the ground, the reddish arrows have been picked up. But in all these processes, a lot of precipitation has happened and condensation has happened, and clouds are now starting to give away, dissipate. They are starting to give away. That's called as dissipation. In this whole process, you will see that this is the development of the occlusion. Okay, and um, if we are to go by the stages here, I'll just clear the markings. Okay, this is the start. I'll just explain it to you so that I come to explain the last two ones again. That you have cold fronts coming in front of each other here. Okay, they've just come. While but in the process that they move, Coriolis force starts operating and a wave develops. This is the second thing. In this wave, what happens is the warm front starts to be picked up, and here is where cloud formation takes place because condensation starts happening. Okay, the moment clouds formation takes place, the latter end, the cold front end, starts having heavy rainfall. The forefront of the warm end starts having condensation. It will not have very heavy rain. It continues till the process that the cold front keeps on pushing itself. Number D now for number 4, and as it pushes, it closes in. Okay, it closes in. I would say this is the foretail of the cold front. This is the back tail of the forefront. So the foretail, tail म्हणजे शेपटी, foretail and the back tail. Okay, हे हळूहळू एकत्र येणार आहे. And in this process, what is going to happen की याच्यामध्ये अडकलेला वॉर्म फ्रंट जो आहे हा वर पुश होणार आहे. Okay, it's going to be pushed up. It's already going up on this side. It's going up on this side and it's being pushed up from the other side. Okay, getting it? Okay, it's being trapped between these two now. Okay, it's going up slowly here because, and that's why the rain is low on this side as such, but it's being pushed up on the other side, and that's why the rain pushing causes heavy rain on the latter side, and that's this side of it. Heavy rain, heavy rain, heavy rain. Okay, moderate rain, moderate rain, moderate rain. At times, in fact, you would not have rain also unless and until you have nimbostratus clouds developing here. And once it so happens that these two arms of the cold front, they close into such an extent that the whole of the warm front actually is picked up here. That's what we are referring to in this diagram. Dissipation. The cyclone is over. Okay, once again, then you'll have to wait for some time for the cold air to come in, the warm air to come in. They'll start coming in this way, but you'll see that as they come into each other, they will change directions, and you'll see that this is how it actually happens as such. आता हे थोडंसं तुम्ही साईडनी जर बघायचं म्हटलं तर हे असे एकमेकांपर्यंत येतात. Okay, from the polar latitude, from the tropical latitude. Okay, when they come, they deflect. When they deflect, they move into each other, and this is how the latter end of the cold front is going to move under the warm, and it is going to be picked up. The picking up is called as occlusion. Okay, and once the whole air mass is going to be picked up, okay, the cyclone is going to dissipate. This is in short the say the Jerkin's theory. The same thing. Okay, टप्प्याटप्प्याने इथे तुम्हाला एक्सप्लेन केल्यासारखं दिसेल इकडे. Okay, now once again we can actually, let me see if we have finished with everything. These are the stages. I've purposely put them separately for you. The first stage is here. Okay, a mid-latitude cyclone is born when two air masses, okay, cold and warm, of different densities, are moving roughly parallel to a front but in opposite directions. Okay, after that, what happens? Under suitable conditions, okay, the frontal surface that separates The frontal surface that separates these two contrasting becomes wave shaped. This is the wave you can see here. Okay, as is usually several and is usually several hundred kilometers long. कारण आपण बघितलं त्या mapवर it's all across the US. That's the second stage. The third stage is where a wave evolves, warm air advances polewards, this part advances polewards to form a warm front. This is the warm front. While the cold air moves in equatorward to form the cold front. So cold front, warm front. Okay, if I'm to redo it, okay, this is the cold front which is moving toward the equator. This is the warm front which is moving towards the poles, the third stage. Okay, the fourth stage. Okay, don't look at this part. This is not supposed to be. My photoshopping has gone wrong there. Occlusion begins. एक टोक. Okay, म्हणजे इथे सापडलेला warm air इथेच सापडून it has come up here. Once the cyclonic circulation develops, general convergence results in forceful lifting where the warm air is overrunning colder air. Okay, warm air overrunning colder air, this part. Then, occluded front develops, wherein the cold front advances more rapidly. This part, the tailing part, than the warm front, and it moves. A cold front begins to overtake. Overtake means it starts lifting. Okay, it's going to lift it here. The warm front. The process is called forms an occluded front, and after this is being formed, within a day or two, the entire warm sector is forced afloat. Entire warm sector is forced afloat. So this is going to be warm. Now upper part. Okay, इथे तुम्हाला color दिसेल तो. Okay, this is the warmer part. And the horizontal temperature density difference that existed between the two contracting air masses is largely eliminated. This is what the stages of the Jerkins theory are. Okay, it's the same thing. I've just explained it, giving you a bit of text matter in it. Okay, and this is how actually a cloud could look. Cloud patterns associated with a mature mid-latitude cyclone. Okay, this is GF. This is GF. This is EA. This is EA. Sorry, EA. Okay, what they've done is they've given us various locations A, B, C, D, E, F, and G. Okay, A is here. Okay, we are more interested in B. What is happening near B? We will have gentle rain because of nimbostratus cloud. Okay, further, what has happened away from B towards A? You have altostratus, you have cirrostratus, and you have cirrus. Okay, so why does this change? Basically, because from a mid-level cloud, it goes to grow into a high-level cloud, cirrostratus, and eventually highest cirrus. Okay, now what is happening at C? C is in between. You have warm air here. You have a lot of warm air. We are referring to this part. Huh? You have a lot of warm air here. What is happening at D? Here the cold front is advancing. So it is forcing the warm air up to form cumulonimbus. Because it's a cumulonimbus clouds, you're going to have heavy rain here. Okay, here you're going to have very gentle and moderate rain. Okay, and E is of course into the cold part. This is into the cold part. This again is the cold part. Okay, it's in between here that you are left with the warm part now. And gradually the whole warm part is going to be lifted up. And where do you see that happening? It is seen to be happened here. Okay, I'll just clear off the confusion by clearing off this. Now look at this part here. Okay, what has happened? This is an occlusion. What does occlusion mean? The warm air has been completely picked up and you are left with cold air everywhere. Okay, and in that also you'll see that in the central part here, Okay, the central part where you have the low pressure here, near the low pressure. You have nimbostratus clouds, nimbostratus. And towards this side, you're going to have cirrostratus and cirrus. Towards this side, you're going to have altostratus. Okay, I'm naming the clouds. You don't have to remember them. I'm naming the clouds just that you may actually help you to understand what actually is happening at what section. The cross-sectional lines FG and AE we have already discussed. Above the map is the vertical line cross-section. Below the map, of course, it's the cross-section along this area as such. So I believe that is the entire process of understanding how frontogenesis takes place. I've tried to explain it in every possible simple way. If you have any queries, we have ample amount of time with us. If you have any queries for me, what I'll do is I'll stop sharing here. I will end the show and I'll come back here. Your questions for me, just in case you have any. Is it clear? See, it's basically a continuation of what we did yesterday. You classified air masses, and then you are letting air masses into each other. Then you let it into each other. If this is the colder and this is the warmer, what they do is it's like म्हणजे आपण ते मी वर्गामध्ये असताना ऍक्च्युली हे सगळं करून दाखवतो की कुस्तीची मॅच चालू आहे आणि during wrestling, you'll see that wrestlers from different countries, if it's an Olympic Games, they come into each other. The referee introduces them, and imagine one is the blue corner wala wrestler and the red corner wala. Red is going to be warm and blue is going to be okay. So you'll see that they start keeping they start taking म्हणजे आपण मराठीमध्ये त्याला अंदाज घेत असतात एकमेकांचा की याला कुठं where is vulnerable. So this is the frontal thing, and this is the wave generating. Okay, eventually we know that in our case, in this case, the cold one is going to be a dominant one, and you'll see that while it is now it starts move, say this is going to stay this is the warm and this is the cold. They move into each other. थोडं वेगवेगळं हे करावं लागणार आहे. And now this is going to push into each other. Now this pushing happens, gives rise to something like this, the कैची, scissor, okay, कात्री सारखं होणार आहे. This push into this. Now because of this push, I should have colored this. Okay, now I'll do it this way. Okay, this is the warmer way. This is the warmer thing, and it's pushing into each. Okay, now what happens is this part is the more aggressive cold part, and this part is where the warm is aggressive. So you're going to have the cold front here, and you're going to have the warm front here. So it's going to push up above my thumb, okay, leading to nimbostratus, and here this is going to push this up. Okay, and now what is happening is that slowly this is going to close, and when this closes, this is going to be pushed up. This is going to be pushed up, and this is called as occlusion. This is called as occlusion. At this end, heavy rain. At this end, you're going to have moderate rainfall. Okay, so that was a possible explanation into this, and that finishes the theory part of your syllabus. Okay, I was just wondering how I would be tackling all these abstract things, but I presume I have been able to express myself through all the diagrams that we could have from the Lutyens book and all the possible animations I could make up from my using my hands and fingers as such, all through, right from composition, structure and composition, and so on and so forth. Next week when we meet, we'll go into the last topic, and that last topic is of course going to be methods of forecasting. We're supposed to be doing any two. Let me see how much. Normally I don't take it up. I leave it as an option, but since we have time at our hands, we could definitely take it up as well. So we'll take these methods of forecasting, and if you have any questions, I'm waiting for your questions for today's content. Otherwise, yeah, Tushar.
सर मी एका डॉक्युमेंटरी मध्ये बघितलं होतं ते क्लाउड बस्ट किंवा डाऊन बस्ट असं म्हणतात. सो ती काय कन्सेप्ट असते?
I would say there are few things, but yes, it's a very interesting thing that you have asked because uh, occluded front ज्यांना समजायला लागतो, okay, those who start understanding occluded front, is there is an every possibility that you would start trying to understand a cloud burst also, or rather thinking about a cloud burst as such. One primary thing we'll see that cloud bursts normally happen in tropical regions. One thing. Secondly, they would happen in a valley region where you have steep sides of mountains and you have valleys as such. What happens is just like what happened in the occluded front. The warm air, the warm air literally असं त्याला आपण उंजळीत धरून असं वर टाकावं. हे द वॉर्म एअर असे वर उचलावं असं तो फिनॉमिना आहे. But only the fact being that you will have a lot of moisture in that particular air mass because it's tropical air mass. Cloudburst in temperate regions will not give you that much amount of rain. What happens is if you have if I say that okay, this is one valley side, this is one valley side, and both the valley sides are actually cutting into the air mass, and because of that the air mass is forced upwards. Now this force enforcement could be convectionally also, and that's why you'll see that cloudbursts happen towards the latter part of the day. Okay, now when it's going to be forced up like you saw in it's not the same. फक्त तुम्हाला एक म्हणतो ना एक आयडिया यावी म्हणून मी त्याचा रेफरन्स घेतो. इट्स नॉट ॲब्सोल्युटली नॉट सेम. इट कुड बी सिमिलर टू द लॅटर एंड म्हणजे कोल्ड फ्रंट जो आहे जिथे हेवी रेन होतं इट्स पुशिंग अप, इट्स पुशिंग द वॉर्म एअर अप. Here the warm air tends to be pushed up convectionally. When it goes up, it cools down. When it cools down, okay, you'll see that it is going to deposit rain. Okay, when deposits rain, it again gets unsaturated, it again moves up. Now, normally in other conditions, what happens is when it goes up, it will move this way or that way. In a mountainous region, and in a mountainous region like the Himalayas, Uttar Kashi मध्ये जे झालं होतं, okay, the height of the mountain is such that the air mass tries to go up. Okay, you'll see that it deposits, it gets lighter, goes up, but you'll see that it's not able to move advectionally, so it has to move further up convectionally, and the further it moves convectionally, you'll see that the more intensified the low pressure gets, the uh, vapor pressure acts, and you'll see that there is a cycling and recycling of moisture in that, and in the process of this getting up is going to deposit heavy rains in that particular in a particular pocket. Okay, and that's why you're going to have, that's in fact called as a cloud burst basically, because it does not move. Okay, seldom will it happen that a cloud burst will move in a at horizontal way. Okay, you'll see that cloud bursts will happen. The history will be that it's actually going to be where the clouds are climbing up vertically, and while they climb up vertically, they'll deposit a lot of rain, which is going to be exceptional rainfall, and that's why it is called as a cloud burst.
Thank you,
Yes,
sir.
Pritam.
Yes, sir, exactly the thing that happened in 2013 in Uttarakhand disaster.
Yeah, Uttarakhand it happened. Yes, Uttarakhand में यही हुआ था.
And in the National Geographic documentary, they showed the entire animation of how the
Oh,
thing happened, how the cloud burst
okay,
exactly took
okay.
place.
If you have the link, you could just post it to our group. Other students also could take advantage of that.
Sure, sir.
Okay, any more questions for me? It's already 1 hour. Oh, sorry, it's 11:30. It's not 1 hour. I've taken you all for 50 minutes. We started at 10:40. If you don't have, or by the time you think about a